Hey guys, this lesson is going to be about, or be the beginning of a new unit on linear equations. So we're going to look at linear equations and inequalities today, and then go into looking at systems of linear equations and inequalities later in this unit. And then, again, this all should be review from what you did in 8th grade or what you do in foundations. So we'll go pretty quickly through all of this, and then hopefully be ready to test on this within about a week or so. It's just not a whole lot to it. But we'll do a quick little review of all of this, and then be ready to move on into some things that you have not learned about yet, some things that'll be new. So by the end of this lesson, you should be able to graph a linear equation or an inequality, I don't know what I just did, but something weird happened, sorry. Okay, so graph linear equations and inequalities and identify their solutions. So a lot of what we're going to do today is going to be things we can do in Desmos. There will be a few things that you can't use Desmos for, but most of what we do will be stuff that we can use Desmos to look at. So, let's go. First thing we want to remember is that a linear equation indicates the equation of something that will form a straight line. So if you remember, linear equations are always written in the form y equals mx plus b. There's no exponents or anything like that in this. It's just straight mx plus b. And if you remember the m part of that, there's a number that goes here and there's a number that goes here. The m part represents your slope. The b represents your y-intercept. Linear equations represent situations involving two variables. So you're always going to have an x and a y. Any point on the graph of a linear equation will make that equation true. So linear equations can take a couple of different forms, or actually 3 forms you could have a linear equation in. I'm only going to teach you 2 of them because the third one is kind of weird and not really necessary. So we're going to look at just slope-intercept form and standard form. Slope-intercept form is that common form that we're used to, that y equals mx plus b. I forgot my plus. So an equation in slope-intercept form might look like y equals 2x plus 3. Remember, in that form, the m is the slope, the b is the y-intercept. That's why we call it slope-intercept form. From that form of the equation, you can see that your slope is that number in front of your x, and your b is whatever value is in the b position. So you don't have to do anything else to be able to figure that information out. It's given to you directly in the equation. Now, an equation in standard form would be written in the form ax plus by equals c. And that means your x and your y are both on the same side. So something like 2x plus 3y equals 4. That doesn't actually tell us anything about the line that that equation would create. From that equation, from the standard form equation, we really just can't really know anything about the equation our line's going to, or the line that our equation would form without putting it first into slope-intercept form. But you can go from standard form to slope-intercept form by just solving for y. In the standard form equation. So we could rearrange an equation like this one into standard form if we wanted to, just by solving this equation for the y value. A lot like what we did when we did literal equations in the last unit. All right, let's get into some examples of, or something else about this, and then we'll get into some examples. Or maybe we'll do examples first. I don't remember. Okay, examples first. So we're going to start just by looking at how to rearrange these two standard form equations into slope-intercept form. And so what we want to do that is we're going to start with, I thought I could do what I thought I could zoom in on where I was at, but I can't. So we're going to start with this one on the left side. And we're going to start by isolating the y. We're going to split the world, and we're going to find a way to get y by itself. So if you remember back to when we were doing literal equations in the last unit, we've got to move the 2x, and we've got to move the 3. And so in order to do that, we're going to do PEMDAS backwards. 3 is being multiplied, the 2x being added to this. So we're going to move the addition first and then undo the multiplication. So we can undo that 2x by subtracting 2x. Because 2x minus 2x will cancel. What I do on this side, I also do on this side. And I'm going to bring down 3y. Now right here, I have 15 minus 2x. Those can't go together because they're not like terms, so I'm going to bring them down. However, because slope-intercept form is y equals mx plus b, I'm going to move the term with the x to the front and the term without the x to the back, so it's in the right order. So when I do that, the minus that's right here is attached to the 2 to make it negative 2. So I'm going to bring negative 2x and positive 15. So I'm just rearranging that so that it's in mx plus b format. Then I've got to find a way to get rid of that 3 that's attached to the y right here. So to do that, since they're being multiplied, I'm going to divide. 3 divided by 3 will cancel. I'm going to divide by 3 over here. So y is all that's left on this side. On this side, I have to divide everything by 3. So 2 gets divided by 3 and 15 gets divided by 3. All of your terms are being divided by that 3. So negative 2 divided by 3 would just be negative 2/3. 15 divided by 3 is positive 5. And that's it. That is our equation in slope-intercept form. If I wanted to check and make sure I did this correctly, I could go into Desmos and graph the original, and then graph the new one, and make sure that they line up in the correct spot. If they overlap, then I know I've done that correctly. All right, then the next one. So same thing, I want to get it into y equals because that is slope-intercept form. So here's my y. Got to get it by itself. So we got to move the x term first. Since the x is being subtracted this time, I'm going to add 2x. So I'll bring down 4y. On the right side of this, 16 plus 2x. I need to move the x to the front and the 16 to the back. Everything's positive, so I'm going to bring 2x to the front, positive 16 to the back. And then I've still got to divide by 4. So y will equal 2 divided by 4 becomes 1/2 or 0.5. 16 divided by 4 is 4. All right, we're going to do a couple more. All right, let's look at another one. So here we've got similar situation. We're going to try to get this y by itself. Now, this is a little bit different because the y is alone. So if you want to, and I think it's a good idea, put yourself a 1 in front of that y so that you remember that that's not just a y, but it's a negative 1y. And that's going to make a difference when we finish solving this. So just like we did on the last one, we'll subtract 3x. I'm going to bring down negative 1y. That minus is attached to the 1 like a negative. Up here, I'm going to bring negative 3x to the front, negative 8 to the back. And then I divide everything by negative 1. Now, remember, dividing by negative changes all your signs. So negative 3 divided by negative 1 turns it into positive 3. Negative 8 divided by negative 1 turns it into positive 8. So I end up with 3x plus 8. All right, we'll do one more together. And then we will let you guys pause the video and try a couple. Wrong thing. Thought that was a highlighter. Okay, so if I want to get that y alone this time, I'm going to take the 4x and subtract it. Bring down negative 3y, negative 4x, and positive 24. So notice all I did was I moved the negative 4x to the front, the positive 24 to the back, put a plus to connect them, and then divide both sides by that negative 3. Negative 4 divided by negative 3 is positive 4/3. 24 divided by negative 3 is negative 8. All right. Take a minute, pause this video, and see if you can get these two rearranged so that they're both in y equals form. Then come back and see if you were correct. If you didn't pause the video now. All right, take a look at that and see if you got the same thing that I got. If you didn't, pause the video again and see if you can follow my work to see where you made your mistake. Check especially for your signs. Make sure you got a negative 2/5. Or if you put negative 0.4 right here, that's also okay. Some of y'all might have done that. And that's totally fine too. That's the same thing. And make sure that you have minus 12 on this one and a positive x right here. All right. All right, now we're going to look at the part of this lesson that can be done mostly with Desmos. And we're going to look at specific things that we want to look for about describing the graphs of linear equations. So we already know that if it's a linear equation, the graph is always going to be a straight line. So if you're looking at a graph and it's not a straight line, you're obviously looking at the graph of something that is not linear. So when you describe the graph of a linear equation, a couple of things you can describe about it. You can describe its slope and you can describe its intercepts. So the slope, remember, is the rate. It's how far it rises divided by how much it runs. Now, slopes can be described in a few different ways. You can obviously describe them with a number, but you can also describe them as positive, negative. So the slope's going to be positive if it's rising from left to right like this. Be negative when it's falling from left to right. A horizontal slope is said to have a slope of 0. And a vertical line has a slope that is undefined. That means you can't count the slope of a vertical line. So one way that helps you maybe to remember this would be Mr. Slope Guy. And some of y'all that had me for foundations last year will remember him. But Mr. Slope Guy looks like this. He reminds us that a positive slope goes up from left to right. A negative slope comes down from left to right. A horizontal slope is 0. And a vertical slope is undefined. Now, you might think this is a silly looking face, and it kind of is. But for a lot of y'all, or a lot of my students in the past, the positive and negative part doesn't really get us. We're really pretty good at, okay, it's going up, we're positive, it's coming down, we're negative. The part that trips people up is, okay, is the horizontal one 0 or is the horizontal one undefined? Well, if you can get his face straight, you'll remember that the horizontal is the 0 and the vertical is the undefined. So just a quick little reminder of how that works. Anytime you see a line that's flat, 0. Anytime you see a line that's vertical, undefined, his face can help you with that. And then x and y intercepts can also be described from the graph. So the x-intercept and the y-intercept are places where they cross the axis. The y one is, of course, where it crosses the y-axis. The x one is, of course, where it crosses the x-axis. In case you have forgotten, in a coordinate plane, the x is the one that goes left to right. The y is the one that goes up and down. So to be able to look at these characteristics, a few things you want to do. If your equation is already in slope-intercept form, so if it's already in y equals mx plus b, you can identify some of these things just from the equation itself. Otherwise, you're going to want to look at a graph of it and be able to tell from that graph whether or what the characteristics of that would be. So I'm going to pull in the Desmos graphing calculator to use with some of these questions. So this first one, y equals 2x plus 4, is already in slope-intercept form. So without having to graph it, I can see that the slope of this line would be 2. And I know that because the 2 is in with the x. And I know that the y-intercept is at 4. Now, to give a y-intercept, you got to have a point. So on the y-axis, that would be at 0, 4. So I know that without ever having to graph it because the equation is in slope-intercept form. Now, I don't know the x-intercept, and I don't know the points that are in the solution and points that are not. Now, I could do some guess and check and find some things that would work for this without having to use Desmos, but since we have access to it, we might as well just use it. So the easiest way to handle that is to go into Desmos and graph it. So y equals 2x plus 4. And so we can look at that and we can see that point at 0, 4, that was my y-intercept. So I can also go to my x-axis and find the point, and if you just tap it, it'll show you the coordinate if you're not great with coordinates. So I know my x-intercept is at negative 2, 0. So I'm going to come over here, negative 2, 0. And then they ask us for points that are in the solution and points that are not. So points that are in the solution are any points that fall on this line that we just graphed. So the two intercepts are points in the solution, but I don't want us to use those because I want us to get some other ones. But any point that exists on this line, and notice if I touch the line and drag across it, it'll show me every point that exists. But any point that exists on the line would be a solution to this. So I'm going to use a couple of stop sign points that I can find. So here's one at negative 1, 2. So there's one point that is in the solution, negative 1, 2. Let me go find another one. And again, you could use some decimal ones if you wanted to. I'm going to go find some nice pretty ones. But you could use decimal points there if you needed to. Negative 4 was another one that I saw. And then some points that are not. I always like to look for some easy ones like 0, 0. If 0, 0 is not on it, I always try to use that one. So 0, 0 is not. And I know that because 0, 0 exists right here, and the line does not go through there. Other points would be anything else that the line doesn't touch. So like 1, 0, 2, 0, 3, 0, or 1, 1, or 2, 2, or 3, 3. All of those are things that the line does not touch. So any of those would be things that would not be in the solution for that. All right, so let's look at the next one. Maybe if I can move this thing out of the way. Y'all, I'm trying to move this, but it's not working. Okay, we'll just pull it back up and do it again, which is kind of annoying, but whatever. All right, now I can move it, but anyway. All right, so we need 3x plus 4y equals 9. 3x plus 4y equals 9. Okay, so this one, I'm not able to identify from the equation my slope and my y-intercept like I was before. Now, I could rearrange it into slope-intercept form like we were doing on the earlier slides and get those pieces of information, or I can just come here to this and be able to get it from this. So if I look at my line that's graphed, my intercepts are on the axis there, so those are easy for me to come up with. My x-intercept is at 3, 0. And I know that one's the x-intercept because it's on the x-axis. My y-intercept is at 0, 2.25. because that's the one on my y-axis. Now, points in the solution and points not in the solution are also pretty easy to find. I'm just looking for things that are on the line. So if I come back to my line here, things on the line would be something like this one down here at 7, -3. Or we can go find another one. One over here at, maybe. I'm trying to show it to y'all at the same time, but my thing's not really working right. At -1, 3. You see how there's one right there? So -1, 3. And then points that are not are just anything not on the line. So again, I like to check 0, 0, 0, 0 is not on the line. I also like to check 1, 1. 1, 1 is also not on the line. So those could be 2 points that are not in my solution. But now we got to figure out the slope. So if you don't have the ability to see the slope directly in your equation, you have to find the slope using 2 stop sign points. And you might remember this from last year. You might remember this from earlier this year in foundations. But stop sign points are points that exist exactly on a coordinate, like where 2 grid lines intersect. So my point at 3, 0 is a good choice. But I'm also going to go find another one, so I'm just going to keep going down from there. And I'm following this line until I find another spot that does that. And so I don't see that until I get right here. Y'all see how that's going to be a stop sign point because grid lines cross each other right there. So I'm going to use that point also. That point is at 7, -3. So to find slope, I go from one point to the next by rising, or for this situation, I'm going to fall, and then running. And I'm going to count how far I do that. So to get from here to here, I fall 3 steps. 1, 2, 3. So fall 3. And then to run from here across to the other point, I would move 1, 2, 3, 4 steps. So my slope for this is going to be negative, because I had to fall, -3 over 4. All right. All right, we'll do a couple more together, and then I'll let y'all try a couple of these. So in this next one, again, we've got one that's in slope-intercept form already. We see that it's y = mx plus b. So I already know my slope is going to be 1/2. And I already know my y-intercept is going to cross at 5. So remember, if it crosses at 5, the point is 0, 5. And I know that information because the 1/2 is the slope, it's with the x. The 5 is the y-intercept, it's by itself, it's the b. Now, to find these other things, I'm going to need to graph it. So I'm going to pull up my Desmos. I'm going to type in y equals. Remember, to make a fraction, you just do division. Now, look, if you were to put your x underneath the bottom of there, look how that looks. It's not linear anymore, right? Some crazy junk. You need to make sure you arrow out beside it to put your x. Otherwise, you're going to have a weird-looking graph. So arrow over and then put your x plus 5. So here's my equation. Here's my line that it created. There's my y-intercept, like I said, at 0, 5. X-intercept is down here on the x-axis at -10, 0. Now, to find points that are in the solution, I'm just going to look for points that exist on the line. Lots of different things you could choose from. But just looking at this, I see that there's one right here at 8, 1, or -8, 1. I see there's another one over here at -6, 2. Or -4, 3. You see, there's all these different ones, and we could go it that way, too, if we wanted to. I'm just going to grab some of the ones that are most convenient. So I'm going to go -8, 1. And we'll go with that -6, 2. And then points that are not in the solution, anything that doesn't exist on the line, like 0, 0, or 1, 1. Those are always my 2 go-tos. You can check others, but those are 2 that are easy to look for. And if they are on the line, then you got to look for something different. All right, and then we'll do the one on the other side. whatever reason it's letting me move it this time, so there's that. So this one's going to look a little different. 2x equals 12. So I'm going to go over here and we'll type 2x equals 12. Now this is a lot different looking because we didn't have a y this time. We just had an x. So we end up with this vertical line. So if you remember Mr. Slope Guy's face, the vertical line has a slope that is undefined. Anytime you don't have a y in your equation, you're going to have a vertical line and a slope that's undefined. Now, the x-intercept and the y-intercept, though, they could still exist depending on what your line looks like. Look and see if your line touches your x-axis. This one does, right here, at 6, 0. So it has an x-intercept. Look and see if it touches your y-axis. This one does not. So your y-axis or your y-intercept does not exist. Does not exist. Points that are in the solution are any points that exist on that line. So that point 6, 0 is 1, but the point above it, 6, 1, is 1. You could use 6, 2. Really anything that starts with a 6, because everything on the line is going to start with a 6. 6 to infinity this way, 6 comma to infinity that way. And then points that are not in the solution is anything that doesn't start with a 6. So 0, 0 or 1, 1 would be things that are not in the solution. Pretty simple stuff. All right, I know that says examples, but try these two. And then try the next two on the next slide. Pause the video and try all 4 of those, and then come back and see if you were correct. Okay, so now that you're back, take a look at the answers that I got for these first 2 and see if you got something similar, especially focusing on making sure you got the same thing for slope and the same thing for your x-intercepts and your y-intercepts. Those have to be exactly that. Now, what you got for your points doesn't have to be exactly what I have here. Could be, but it doesn't have to be exactly that because there are other things that it could have been, but these are just some examples in case you were having a hard time with what you were working on here. Now, for the ones that were, I was going to say my pointer's not working. For the ones that were in the solution, yours have to end in 5 on this one. If they don't, yours are wrong. Now, here there are other things that it could have been other than these. You just want to make sure you're picking points off your line. Neither of these went through 0, 0 or 1, 1, so I stuck with that and let those be my 2 points that they did not go through. But again, sometimes they could go through 0, 0 or 1, 1. So don't assume that they won't always, because it does happen sometimes. So be careful. All right, and then for the next ones, take a look at these and see if this is also the same thing you got. Again, you had to have, this is your slope. Now, this one you could have gave as a decimal 1.5. This one had to stay 2/3 because it was 2/3 here, and that would be a repeating decimal. And then make sure your x and your y-intercepts are the same. This was 5.3 repeating. You could also put it at -5 1/3. Either one is okay. And then here are your points that are in the solution. Again, you could have had different points in that, and these are the points I used for those that were out. Focus on making sure your slope and your intercepts are the same as what I have here. Your points should be pretty simple because you got them straight off of Desmos. So hopefully you got all that correct as well. Okay. So now that we can deal with linear equations and answer some things about them, we need to focus on looking at linear inequalities now. This is very similar to equations, but instead of an equal sign in it, we're going to deal with something with an inequality symbol. So 2 things are different about the graph of that. Still going to create a line, but you could have 2 different types of lines that are created. You might see a solid line, or you might see a dashed line. Now, inequalities that are graphed with a solid line are ones that have the equal to bar in the symbol. So if they have a less than or equal to bar or greater than or equal to, that's when you're going to use a solid line. That tells me that that solution can be included because it could also be equal to that particular number. Dashed lines are for the symbols that don't have the equal to bar. So just less than or greater than. That means that the points on the line are not included because it can't equal it. It has to be less than or more than, but not equal to it. So points that fall on the solid are a part of the solution. Points that fall on the dashed are not. So you want to make sure you keep that straight. Lots of people mix that up. So pay attention to what kind of line you have and make sure that you only use points on the solid line if you're using a point on a line at all. Then in addition to that, having points on the line, you're also going to have one side of the graph that is shaded. And that depends on what symbol you have. It's going to shade above the line if you've got a greater than symbol, or shade below the line if you have a less than symbol. But it's going to be shaded on one side to show you where all the possible solutions are. So any point in the shaded area is a part of the solution. Okay, so let's go look at some examples of this. This is really simple stuff, and Desmos can do the graphing part for us. So as long as we know what to look for, we should be pretty easily able to do what is here. So here is our first couple of examples. Now, before you even graph this in Desmos, you should be able to look at that inequality that's given to you and be able to tell immediately what type of line you're going to have, whether you're going to have a solid line or a dashed line, simply from the symbol that's used. So like this one says y is less than or equal to 2x plus 4. Because we have an equal to bar with our less than symbol, we automatically know that this is going to be a dashed line. I'm sorry, solid line. Inside my head today, y'all. So that means any point that is on the line or any point that is in the shaded area could be a part of the solution. Points that are not in the solution are going to be only points that are outside of the shaded area. So let me show you that. So if I go to graph this in Desmos, y is less than or equal to 2x plus 4. And by the way, you can get your less than or equal to symbol in Desmos from right here. So if you need any of those symbols, you can type them also. Like you can type a less than and then type equal right behind it, and Desmos will create less than or equal to. But you can also just tap it down here in the keyboard setting in Desmos. So, all right, if that's how that graphs, look at the graph of it. So we've got a solid line, and we have shading done on the underneath part of it because it's a less than, so it's shaded below the line. When I say below, I'm thinking if I'm looking vertically at my y-axis and the line is here, below is underneath that way. So all of this over here would be solutions to this and every point that exists along this line. So when they ask me for 2 points that are in the solution, I'm going to give either a point on the line or a point that's in the shaded area. So just for the sake of having a little bit of both on our notes, we see that we've got a point at 0, 4 or a point at negative 2, 0. I'm going to put one of those on my list. So I'm just going to put 0, 4. And then I'm going to give a point that's in the shaded area, like 0, 0. Now, you could have picked any point that was over here. You didn't have to pick those two, but that's just what I chose. And then to get some that are not solutions, we want to pick some that are out here in the white area. So anything that's out here in the white would be not a solution. So I might go negative 5, 5. That would be not a solution because it exists in the white. Or I might look at negative 5, negative 5 even. Okay, so those are just some points that exist out there. Now, if you're not great with points, most of these questions are going to be multiple choice where they give you some points to look at. You can always just type your points in. Sorry, y'all, hang on. Go away. Negative 5, 5. And it's going to graph that for you in Desmos. So if you accidentally graph things backwards and stuff like that, you might use Desmos to just check. And I can see that this point that I just graphed, it came up in green right here, is not in my shaded area and not on my line, so it is not a solution. I can check one of the ones that is a solution, like 0, 4. And I can see that it pops up on my line. Or if I try 0, 0, I can see that it pops up in that shaded area there. So you can use Desmos to check your points. It's a good idea to do that, especially if you know that you have a tendency to accidentally graph things backwards sometimes. Lots of us do that, so don't feel bad if it's you. Just recognize it and learn from it and do better. So that's how we'll work that. Let's look at the one on the other side. So again, we should be able to look at this and tell immediately without graphing it whether we're going to have a solid or a dashed line. This one, because it doesn't have an equal to bar in the symbol, it's just a less than, it's going to be dashed. And that tells me that points that are in the solution can only exist in the shaded area. They cannot exist on the line. Points that are not in the solution would be on the dashed line or out of the shaded area. So if I go back to Desmos, I type that one in, 4x minus 2y is less than 16. 4x minus 2y is less than 16. There's my line. You can see the dashed part here. So to find things that are in the solution, I need only points that are out in this area, not points on my line. So to do that, I'm just going to put down some points. So again, I like to check 0, 0. So 0, 0 is in the shaded, so I'm going to use it. And then anything else you want to, like 0, 5. You know, that's up here in the shaded area. I could use that. Or negative 5, 5. That's over there in the shaded area. Anything that exists in that red section would count. And then points that are not in it are going to either be points that are on the line or points that are in the white. So I can see that 5, 0 is in the white. I'm going to put it. But I'm also going to put one that exists on the line, just so we have an example of that. So like I have this point that's my intercept. Maybe. That's at 4, 0. I was trying to get it to show up for y'all so you could see how you could see it. Or I could use this point that's my y-intercept at 0, negative 8. Both of those would be on the line but not solutions because the line is dashed. So this is a really simple concept to see and to figure out. Just because most of it can be done with Desmos, as long as you know what you're looking for. And like I've told y'all before, when you take your state test, it is very, very easy to pass it using Desmos if you learn just what to look for. Desmos is not always going to answer the question for you, but like on a question like this, as long as you know what you're looking for, you should be very successful on these types of questions on that state test and should be able to answer them very quickly without running out of time. So my other groups have been able to work these pretty quickly independently. So I'm going to let you guys go to the next slide. And I want you to try the 2 on this slide and the 2 on the next slide that says you try some. And see if you can get some points that are in the solution and some points that are not. And see if you can determine whether your line should be solid or dashed. And then if you're not sure about what you're doing there, come back to the video and you can watch me work through some of that too. But if you're pretty sure you know what you're doing, then stop and try just a few of them on your own to make sure. So if I was going to work this next one, I'm going to graph it. X minus 2. I've got a dashed line, which I could have known that already because I don't have the equal to bar. So I need to find points that are in the shaded area to find points that are part of the solution to this one. So lots of points over there in the shaded area. I see that 5, 0 is in it. So I'm going to graph 5, 0. Or I'm going to write 5, 0. I also see that negative 2, or 2, negative 2 would be in it. There are lots of other things you could have picked. So if you didn't pick those, that's fine. But 5, 0 was over here. 2, negative 2 was down here. I needed 2 that were in the shaded area. And then ones that are not in the solution. I'm going to give one from the line and one that's not. So like I have this point at 2, 0. It's on the line, not in the shaded area, so it is not a solution. Or a point at 0, 0. Not in the shaded area, so not a solution. Alright, same thing for the next one, maybe. I'm trying to pick this up and move it, but I'm failing epically. Well, that just happened. 2, 0, 0, 0. I know I did 2, negative 2. I don't remember what this one was. It might have been 5, 0, I think is what that was. if it wasn't 5, 0 works. So there's that. All right, so for the next one, if you worked this one or if you were struggling with it and you're still watching the video because you were having a hard time, you should have gotten this as a solid line. And again, we know that because it has the equal to bar. And then we'll graph it and find some points that are in the solution for that. So 3y, whoa, go away. 3y minus 2x is greater than or equal to 15. All right, so now for points that are in, I can pick points on the line or points in the shaded. So I'm going to go with 0, 5, because that's right here on the line. And I'm going to go with negative 5, 5, because that's in the shaded area. Points that are not in the shaded area, like 0, 0, or 1, 1, could be points that are not in the solution. You could not put points from the line in the not in the solution part. All right. For these next ones, same thing that you were just working on. Hopefully you are already able to do these and have moved on. But if you're still watching because you needed some more help, this one would have had a solid line because we have that equal to bar. This one would be dashed. And again, you pulled this in Desmos, found some points that were in the correct area. So y is less than or equal to negative 2x plus 3. So anything on the line or in the shaded area would have worked. So 0, 0 works, 1, 1 works, right? Because 1, 1 is right here on the line. So we don't ever get to use 1, 1, but here it is, 0, 0, and 1, 1. Points that are not in that area would be not solutions. So I can see this point at 0, 5 is outside. Or I can see that this point at 2, 1 is outside. There are lots of things you could choose there. I'm just picking a few just to kind of illustrate this for you. All right, and then on the other side, I like how it lets me move this time. 2y plus x is greater than negative 12. 2y plus x greater than negative 12. All right, so this has a dashed line, which means I don't want to pick points on the line for my solution. Only things in the shaded. So 0, 0 is in the shaded. 1, 1 is in the shaded. I'm just going to go with both of those because they're real simple. Things that are not shaded or are on the line would be things that are not in the solution. So like 0, negative 6 is on the line, but not part of the solution because it's dashed. Or negative 5, negative 5 is completely outside of the shaded area. So that would be not a solution. That should be very simple for you, I feel like. As long as you don't make a mistake when you're graphing it in Desmos, you should find yourself easily able to do questions asking about whether points are in the solution or not. So let's look at some of how this will be tested. So here's an example of a question from the practice test about the solution to an inequality. And you can see in this that they've drawn the line, it is dashed, and that they have shaded this underneath portion here to show where the solution would be. Now from this, you should immediately say, okay, solutions are not on this line, and they are not in this area up here. So only things in the shaded area would work. So they ask you to pick from this list over here 2 answer choices that are solutions to this inequality. If it was me, I would just go through here and graph these answer choices and see whether I get things that are solutions or not. So negative 3, negative 8. Remember, you go left to right first. So negative 3, negative 8 is right down here. Negative 3, negative 8 is definitely in the shaded area, definitely a solution. Now, if they give you some fractional ones, change them to decimal so that there's something you can work with. Like 11 over 4 is 2.75. 3 over 2 is 1.5. So that kind of helps you have a little something to kind of think about and look at. So if I look at 0, 2.75, I'm going to look right here at my trying to pinch and zoom for y'all. At my graph, maybe. Okay, that's about the best it's going to let me do. And that point, 0, 2.75, is going to exist at 0 and then up to 2.75. So 2.75 would be like 2 3/4, right? 2 3/4. So I'm going to go up to 2.5. 2 3/4 is going to be right there on the line. Now, what we already know is that points on the dashed line are not solutions. So this is a no. Now I'm going to go to 10. That's up here. 210 is definitely out. I'm going to go 3, 2, which is right here. That's on the line again. That's out. So it must be this next one, but let's look at y. 4, 1.5. Now 1.5 is going to be halfway between 1 and 2, because 0.5 is a half. So I'm looking at this again. Here's 1, here's 2. Halfway is going to put me right here. It looks very close to the line, but it's definitely under it. We can see the line is cutting above that. So because it's under the line, it's still in the shaded area, it would be our solution there. I know it looks like B is kind of close like that too, but B I think is on the line where E is not. So we'll use A and E for this question. All right. Now this one asked us about which of these ordered pairs is on this graph. Take a minute, pause the video, go to Desmos and see if you can get an answer to this, and then come back and check and see if your answer was correct. All right, if you did not go to Desmos, you need to go to Desmos and try this question out. All right, so we're back. You should have, for this one, gotten B and C. Those are the only 2 points that fall on the line. If you didn't get that, go back and check it and see if you can see. Maybe you mistyped something in, something like that, but B and C are the only ones that would have worked there. And then our last question. This one asks us to tell which of these statements are true about this line, and you had to choose 2 answer choices that were correct. So you notice the top 3 are just points. We might be able to look at our graph and tell whether it's going to go through those points or not. The bottom 2 are equations. Easiest way to look at those 2 and tell which one it is just go to Desmos and graph each one of them and see which one it works out to be. But if I look at the top 3 answer choices, I can do that from right here. If I go to -4, 0, that's right here. My line does not go through that point, so this is not a solution. 0, -4 is down here. My line does go through that point. This is a solution. 36, 28. Now, my graph only goes to 10 in any direction. But just think for a minute logically about this point, 36, 28, which would exist 36 this way and 28 up this way. So somewhere far, far away in this direction if I was zooming way out. So if it would end up way over here in the positives and my line is going this way, that line is never going to go through something that exists way up here. So I know that that point is not going to be on the line either. So then it comes down between these 2. Again, that's a Desmos question. You can just go graph them in Desmos and see which one ends up being the correct one. And you would find that E was the correct answer to that part. Okay, that's the end of this video. If you will make sure to save and submit your notes. And y'all have a beautiful day.